The graph of y equals f of x on the closed interval 0 to 4 is shown above. Which of the following could be the graph of y equals f prime of x? Let's take a look. F of x is decreasing, so its derivative would have to be negative. F of x is increasing, so its derivative would have to be positive. The only one that represents a negative going to a positive is C. No other option is really even viable. All right, looking at this one. We've got a function defined piecewise. Which of the following statements about f are true? The limit as x goes to 1 from the left and right are equal. The derivative limit as x goes to 1 from the left and right are equal. And the function is differentiable. So let's take a look at the first one. The limit as x goes to 1. So if I can put in 1 here, it's going to say 1. And if I put in 1 here, it's going to say the natural log of 1, which is actually 0. Therefore, we're kind of done with this one pretty quick. If the limits aren't equal, then it's not continuous. If it's not continuous, it can't be differentiable. Kind of lame. Here we've got a good one. The function f is defined by f of x equals 2x cubed minus 4x squared plus 1. The application of the mean value theorem to f on the interval from 1 to 3 guarantees the existence of a value c between 1 and 3 such that f prime of c equals. So the mean value theorem, we've done both sides. We've done the mean value and we've done the mean derivative. And so this one would be talking about the mean derivative. So we need to find the average rate of change, which would just be putting in, our f of 3 minus our f of 1 over 3 minus 1. So if I put in f of 3, and again, this would be a no calculator. 2x cubed, so I've got 54 minus 36 plus 1. I think that's 19 minus f of 1 would be 2 minus 4 plus 1. 1 over 2. And that equals 9. So the average rate of change is 9. Therefore, because we know this function is continuous and differentiable everywhere, both parts of the mean value theorem apply. The velocity v in meters per second of a certain type of wave is given by v of h equals, so we've got a velocity, where h is the depth in the meters of the water through which the wave moves. What is the rate of change in meters per second per meter of the velocity of the wave with respect to the depth of the water when the depth is 2 meters? What is the rate of change of the velocity of the wave? So we need to derive again 3, so root h, so 3 times 1/2 h to the negative 1/2. And then we just got to plug in our 2. So I've got 3/2 times 1 over root 2, which is right there. Not bad at all. Let f be the function with the derivative defined by f prime equals x cubed minus 4x. At which of the following values of x does the graph have a point of inflection? All right, so we've got a derivative. We're looking for a point of inflection, so that will be where the second derivative equals 0. So the second derivative is 3x squared minus 4. It equals 0. at plus or minus root 4 thirds, which is the same as 2 over root 3, plus or minus. Let's take a look. Negative 2 over root 3, 2 over root 3. Throw in a larger negative value. I think we get something like a negative, I don't know, negative 10, whatever. We're going to get a positive value here. If we put in a 0, we get a negative value. And if we put in a large value, we get another positive value. So we actually would probably have 2 points of inflection of this guy. But the only one, it doesn't have both of those up there, it just really just has the 1. So that was a pretty obvious one.